Right. So in this session, we will be mostly discussing about the cross product operation, which is the last of the vector operations that we'll be learning about. So we have come to the very end of vector analysis now. So let us understand, to begin with, the definition of cross product. Cross product is also known as the vector product. So even as the city prepares for the cyclone today, let us continue with our endeavor to learn vectors. So the symbol used for cross product is this. Okay. So this operation is read as the cross product of vector or vectors A and B. Cross or vector product. So in short form, we just read it as E cross B. That is just a symbol. Now let us understand the definition of the operation. So the definition of the operation is that this is given by the relationship E cross B equals EB sine theta into a unit vector n cap, where I'll explain each of the terms, especially n cap over here. N cap is a unit vector, as you might guess, but it has a special relationship with A and B. So first of all, E is magnitude of the vector E on that side. B is magnitude of the vector B. And theta, as usual, is the angle between A and B. But more importantly now, n cap is a unit vector which is perpendicular to the plane formed by vectors A and B. It is given by the right hand palm. We'll be discussing a lot about application of right hand palm rule today. Right, so this is the definition of E cross B. Just note this down and let's get started with this. Okay, so let us understand this in more detail over here. So if A and B are what we call non-collinear vectors, That is, they do not lie along a straight line. Or in other words, theta is not 0 or 180 degrees. So anytime we are talking about two arrows which are either making an acute angle, yeah, I move on. Okay. Or they are making an obtuse angle, but the angle is neither 0 nor 180 degrees. This is an example of an acute angle less than 90 degrees. This is an example of an obtuse angle, but they are not lying along the same line. Okay. In such a case, the vectors A and B will form a plane. They define a plane. And you can say that is the plane of parallelogram formed by them. In such a case, you can form a parallelogram with the vectors A and B, and that parallelogram is a two-dimensional figure. So it lies in a plane. Okay, so they form this sort of plane. Whereas, I'll come back to the other point above. Whereas, for two collinear vectors, A and B, suppose you're talking about two collinear vectors, that means they lie along a common line. Or in other words, theta is either 0 or theta is 180. In that case, the two vectors we are talking about, they lie either like this or they lie like this. That is, the angle between them is either 0 degrees or the angle between them is 180 degrees. So ऐसे केस में क्या होता है? They don't define a unique plane anymore because they don't define any parallelogram. In such a case, A and B do not define a unique plane. Because a line has infinite planes passing through it, but two lines which are not overlapping with each other, they define a unique plane. Okay. So we will see that when this is the case, then n cap will be defined. So for such a case, n cap for E cross B is the unit vector perpendicular to the plane of A and B, that unique plane of A and B. Okay. And we'll see in this kind of case, n cap does not exist. But we'll see in any case what happens in such a case is that E cross B has a magnitude of 0 because sine theta is 0. But in this case, A cross B is non-zero. Okay. So that's beside the point for the moment. The more important thing is we understand the concept of collinearity, meaning there is no common plane. There are infinite planes that pass through A and B. There's no unique plane. Whereas non-collinearity, that means they're not lying along a common line. The moment two vectors are non-collinear, they define a unique plane. Okay, so that's the more important thing. So anyway, for the benefit of everybody, I'm just first taking you through the definition of cross product. So just go through this once more, then we'll come back to the case of collinear and non-collinear vectors. Yeah, yeah, Rusba, we will understand the right hand palm rule in a lot of detail actually. Here I've just mentioned it uh, as a definition that we use it to define. Okay, but the proper meaning of right hand palm rule, how to apply it, I'll explain in a lot of detail. Let us first understand the concept of non-collinear versus collinear vectors. Okay, so hope this point is clear over here. So just let me demonstrate this in a sort of physical sense. Okay. So pay attention to the video here, what I'm doing. See, so the moment you have two arrows, which are not lying along a common line, they are either making an obtuse angle like this or they are making an acute angle like this. Now you can see that they are defining a plane. They lie along one unique plane. There's only one unique plane that captures both these lines, this and this, okay, whether they are like this or like this. But the moment they become along a common line, like this, okay, that is they're in the parallel direction or they're like this, in the anti-parallel direction. Now they are just one single line. So there are infinite number of such planes. Now, there are infinite number of such planes that in which both of them lie. So they don't define a unique plane anymore. So that is what we mean by this statement, that the moment the vectors are becoming non-collinear, they define a unique plane. Whereas the moment they are collinear, there is no unique plane that defines them. So such an n cap does not exist. A unit vector which is perpendicular to both of them, there are infinite such vectors. So there's no unique n cap. Okay. So that is it. So now let us come back to the definition. So E cross B is given by EB sine theta n cap. So next thing we understand is that the vector operation of cross product, the output of this thing is a vector quantity. So it gives or it results in a vector quantity. Unlike scalar product or dot product, which gives us a scalar quantity, okay, such that its direction is along n cap, where n cap is a unit vector perpendicular to both A and B. Now the next question becomes that how do we decide the direction of n cap? So the direction of n cap is determined by the right hand palm rule. So let's understand right hand palm rule in detail once more. So right hand palm rule kya hai, that for E cross B operation, okay, orient your right hand such that the thumb points towards E or along E. The fingers point along B. So whichever vector is written before the cross, the first vector, we have to keep our thumb along that vector, and whichever is written as the second vector after the cross, then our fingers have to point along that. Then the direction in which the palm faces is the direction of n cap. Okay, so this is the right hand palm rule. So I will come back to giving you the words for it, but let's just understand this with an example. So suppose we have got the vector E like this, and we've got the vector B like this. So this is the vector B, and this is the vector E, and we want to calculate E cross B over here. So we'll see that we have to now orient our hand, right hand, such that when we place it on the diagram, our thumb should be pointing along A and our finger should be pointing along B. So now we'll have to orient it such that our right hand thumb is facing along this direction, and our right hand fingers are facing along this direction. Okay, so you'll see that our palm is on top of one. This is our. So that means the palm is facing in which way? It's facing towards us. It's coming out. In this case, A cross B will be in the direction coming out of the plane, okay, of the screen on which you are seeing this. Okay. So this is like one example of application of cross product of right hand palm rule. Okay, we'll do more examples. So just first note down this point. Yes, that is correct. There are only two possible directions for a given, plane. One is coming out of the plane, the other is going into the plane. So how we decide whether it is coming out or going in, that is as per the right hand palm rule. So hope that is clear, Farhan. Good. Okay, so let's see some more examples of directions. So are all of you clear with this first example of palm rule application? Any doubt, please ask me on chat. So you have to just place your right hand in the diagram, exactly in the plane of the paper you're drawing the diagram, such that your thumb should be pointing along A and your finger should be pointing along B. So if you have to place your hand in such a way, your palm will be either facing straight towards you or it will be facing into the plane of the paper. Only those two possibilities are there. So that tells you whether your end cap is coming out of the plane or going into the plane. So let's do a simple example problem like this, where we indicate the direction of A cross B as going into the plane or coming out. In each case. Okay. So in option 1, let us say A and B are like this. In option 2, yeah, so just work this out and start sending me your answers. Okay. Correct. Yeah, Farhan, your first two answers are correct. Rakshit correct. Amok correct. Arpriya correct. Yashuvardhan correct. Snigita correct. Manas correct. Dhruv correct. Good. So people are getting this correct. So now you can see that in this case, you will have to keep your thumb like this and the 4 fingers like this. So in this case, it's your knuckles which will be looking at you. That means the palm is facing the other way. Okay. That means this is into the plane. Similarly, now this one is a little awkward, the second one. Now you'll have to place your hand like this. In the second one, let me just try and show you. Okay, so for example, for the second one, if your E cross B is like this, so hope you can see. So E is pointing like this, as you can see. E is pointing like this, and B is pointing like this. B is pointing like this. So for E cross B, I'll have to put my palm like this. So you can see it is facing towards me. You can see for E cross B, I'll have to put my palm like this. So it is facing towards me. Facing towards me. So that's why it's coming out of the plane. So here again I'll have to place my hand such that my thumb is pointing like this and my fingers pointing like this. So my palm is facing towards me. So this is coming out. Okay. Now similarly, this one will again be coming out. This one will again be coming out. And this one will again be into the plane. So again, if you place your hand this way, you can see your knuckles are facing you. The palm is other way. Okay, so hope each of the options is clear to all of you now. Okay, good. So this is how we determine the direction of n cap using the right hand palm rule. Now another example of this kind of thing would be that suppose we now draw two-dimensional plane. So this is a two-dimensional surface. So E and G are just names given, na beta. जो भी vector पहले cross product था, okay. Yeah, Pratinav, it's okay. The bandwidth is low, then you just see the recording later, okay? Don't worry about this. I cannot, suddenly change the bandwidth of the network. So suppose the vector E is lying over here like this, within this plane. And the vector B is lying like this, in this plane. So now in this plane, you can see that the direction of n cap will be pointing like this. This will be the direction of n cap, or E cross B. Whereas you will also see that if we are doing B cross A, then the direction of that will be opposite to that. that's the next point we'll understand, that for B cross A, the direction will be taken by thumb towards B and fingers towards A. So whichever vector comes before the cross product, that is where your thumb is pointing. Okay? And whichever vectors comes after the cross product, that is where your palm is pointing. So therefore we understand here that therefore E cross B and B cross E will be opposite each other. If one is coming out of the plane, the other will have to go into the plane. If one is coming into the plane, the other will have to come opposite to the plane. So like that, if you're doing P cross Q, then P will be where your thumb is and Q will be where your fingers are. If you're doing C cross D, so A, B, C, D, these are just names given. The important thing is you're doing cross product of two vectors. So जो भी vector पहले आ रहा है before the cross sign, that is where your thumb has to be oriented. And whichever vector is coming second after the cross product sign, that is where your fingers have to be oriented. So hope this point is clear, Atharva. If you're taking cross product of P and Q, then it is P cross Q. So put your thumb along P and your fingers along Q. Okay, whereas if you're doing Q cross P, it has to be other way around. Okay. So in fact, that is why we'll understand later that this is one of the non-commutative operations. There is, there is, Baba. तभी तो 3-dimensional हो गया ना, because E, B and E cross B don't lie in a plane. E cross B is perpendicular to the plane of A and B. So it is a completely 3-dimensional operation only. It exists only in 3 dimensions. We cannot define A cross B. Alright, so now let us also do another example where we understand this in more detail. Now calculate mod of A cross B and express A cross B as a vector given this situation. So given that this is our XY plane, now in this plane, I'm drawing vector E like this. And vector B like this. Where B has a magnitude of 20, E has a magnitude of 15, and this angle is 127 degrees. Okay. So now we just use the formula of A cross B, which I'll just give as a reminder to all of you. A cross B is EB sine theta n cap. Now just use both the things. The formula for magnitude of A cross B, which is AB sine theta, for that everything is given to you here. Okay. And the right hand palm rule to understand the direction. So here remember we are talking about our standard Cartesian coordinate system. So if X and Y axis are like this, then which axis is coming out of the plane? It is the Z axis which is coming out of the plane. Correct. Utsav, it is correct. The magnitude of A cross B you given is correct. So you understand here that magnitude of A cross B is mod of AB sine theta n cap, which is nothing but AB sine theta, which in this case is nothing but 15 into 20 into sine of 127, which is 15 into 20 into sine of 53, which is 4 by 5. So that becomes 240. So mod of A cross B becomes 240. That's the first thing. Okay. Now the next thing is the unit vector. Okay. Now you have to place your thumb like this, okay, and orient your fingers like this. So when you do that, you will see your knuckles will be pointing outwards. That means palm is into the plane. So that means E cross B is into the plane. So that means it is along minus k cap. Okay. So expressed as a vector now, E cross B will become its magnitude, which is 240, multiplied by its unit vector, which is minus k. Okay. So this will become the answer to the second part. So the unit vector which is into the plane, this means that उसका जो n cap है वो कौन सा unit vector होगा? It will be along negative z axis. Okay, people, so hope this is clear. So in this particular diagram, I have given the xy axis like this. So into the plane is now represented with which unit vector? Minus k. In the earlier diagrams, I had not given any xy axis, so I did not say it's minus k cap or plus k cap. I just said that it's coming out of the plane or going into the plane. But here we are given a reference of the xy axis, so immediately it becomes like this. Okay, people, so hope this is clear. Alright, so now let's understand few more things about cross product. So E cross B is AB sine theta n cap. No precise value, there is precise value, no beta. That's why in the last question, Vatsal, n cap's direction became what? Minus k cap. So the precise value of n cap is minus k cap. Had it been coming out of the plane, it would have been plus k cap. Precise value है तभी तो कैसे precise value आ रहा है? By using the right hand palm rule. I'm not saying that n cap can be into the plane or can be out of the plane. It has got to be one unique value. It has to be one defined value. That's why it's precise in fact. Okay, now next point is that magnitude of A cross B, which we just saw above, is AB sine theta. It is mod of AB sine theta n cap, which means that it is just AB sine theta. Now, if you notice what is AB sine theta, it has an interpretation, it has a significance. So whether A and B are making an acute angle like this, or A and B are making an obtuse angle like this, there is a particular interpretation to AB sine theta, and that is that if you drop this perpendicular, it is B sine theta. This length here is B sine theta, and this length here is E. In other words, if you look at the parallelogram formed by A and B, the area of this parallelogram, the area of this whole parallelogram, that is nothing but base into height. And similarly here also, if you look at this parallelogram formed by A and B, now you'll see that here also, B sine theta is nothing but this perpendicular distance. This is B sine theta. Because if you just draw this right angle triangle here, you'll see B sine theta is the same as sine of this angle. So sine of this angle is giving you this perpendicular. So that's B sine theta. And this is nothing but E. Okay. So you can see that mod of A cross B is nothing but AB sine theta is base into height of the parallelogram with sides A and B. In other words, it is area of the parallelogram with sides A and B. So this becomes the geometrical significance of mod A cross B. This is the interpretation. Geometry. Okay, so, and of course, if the angle theta is 0 or 180, there is no area. That's why it becomes 0. So within this, you can see that also, if theta is 0 or theta is 180, okay, mod of A cross B becomes 0. there is no parallelogram form because they are either parallel or anti-parallel. So the magnitude of A cross B becomes 0, and we cannot define any such n cap because there is no unique plane containing E and B. Yes, we can do that. That's correct, Aditya. We can interpret A cross B also as E multiplied by B's projection perpendicular to B. Here you can see that B sine theta is the component of B perpendicular to E. So like dot product was the product of E's magnitude with B parallel to E. Cross product's magnitude becomes product of E's magnitude with B's component perpendicular to E. And that's why it becomes the area. Also, if you want to find the area of the triangle formed by A and B, so if this is A and you now draw B like this to form the vector triangle AB, you see the area of that triangle is half of the cross product's magnitude. And the area of this triangle will be exactly half the area of this. Okay. So, area of triangle formed by A and B is half of magnitude of A cross B, or half the area of the parallelogram. Okay, let's move on to some more properties of cross product. So next, we understand that E cross B is minus of B cross A because magnitude of A cross B, which is AB sine theta, and magnitude of B cross A, which is BA sine theta, are equal. But their directions are opposite. As we've seen earlier, if one of them is coming out of the plane, the other is going into the plane. So therefore, E cross B is in fact not equal to B cross A because it's minus of B cross A. So in other words, cross product is what we call a non-commutative operation. Okay, so the important point to remember here is that it is non-commutative. I mean that it is minus of this. A cross B is minus of B cross A. Unlike dot product, which was commutative. Yes, we will discuss beta. It is distributive in fact. All right. Next point, we'll see that what we've already caught on, that it's a distributive property, or it's a distributive operation. A cross of B plus C can be expanded as A cross B plus A cross C. So it is distributive in nature. So you can understand this with an example, why this is happening actually. Suppose we have three vectors, B like this, which is 10 in magnitude, B like this, which is, let's say, again 10 in magnitude, but such that this angle is 37 degrees, okay, and C, which is, let's say, 8 in magnitude, but such that this angle is 30 degrees. Okay. So now show that A cross B plus C is equal to A cross B plus A cross C in the above example. Okay. Wait, let us just make this a little bit easier, because here the value will cause us a little bit of problem. Okay, so let us take this angle also as 30 degrees. Okay, Dhruv, is it clear? So just try it out. So this is going to be a little bit lengthy, but just try to show that left hand side is equal to right hand side. So left hand side में क्या करोगे? First you will do the operation B plus C, okay, and then you will take its cross product with A. Whereas right hand side में you will directly do A cross B and then add it with A cross C. Yeah, Harpriya, you can use component algebra. You can use IJK form. Try this. Okay, so let's do the left hand side first. So in the left hand side, you have to calculate E cross of B plus C. So in this we know A is a vector like this. Of magnitude 10. But what about B plus C? So what about this vector? So for this we'll understand that the vector B was like this. And the vector C was like this. Now you'll see that we are at an advantage if we use component algebra. So let me arbitrarily define this angle as my x-axis and this angle as my y-axis. I mean this axis as my y-axis. So I can write the vector B as 5 root 3 I cap plus 5 j cap, and the vector C as 4 root 3 I cap minus 4 j cap. So the vector B plus C becomes 9 root 3 I cap minus j cap. Okay. So now I know that the vector B plus C will look something like this. The vector B plus C will be something like this. Which will have this component equal to 9 root 3 and this component equal to 1. Just a moment, this is plus 5 minus 4. Okay. So now I know that in comparison to this, how will the vector E be looking? Okay, so first just absorb this information, then we'll go further. Okay. Okay, so are we clear up to this step, everyone? This step, right? Okay, so now let's come back to our left hand side, which is, so we want to do E cross of B plus C. So in this, let us say, just to make the understanding easier, okay, let's say that B plus C is a new vector D, suppose. So I'm just assuming. So D is this vector now. D is a vector like this. जिसका मुझे मैग्नीट्यूड मैंने कैलकुलेट नहीं किया है, बट आई कैन सी दैट this component of D is 9 root 3 and this component of D is 1. It's unit. Okay. This is the vector D. Whereas what was my vector E? My vector E was this. It had a magnitude of 10. And between them, this will be the angle theta. So if this is D, then you can see that D sine theta is equal to 1 and D cos theta is equal to this. Okay. So for example, now I want to find mod of A cross D. That is how much? It is ED sine theta. So that will be how much? 10. Whereas for example, if I want to find A dot D, it is how much? ED cos theta. It is 90 root. So in other words, mod of A cross B plus C is becoming 10. Okay. That's the first thing. And the second thing is you can see the direction of A cross B and direction of A cross D. ये क्या होगा? This will be into the plane because A is like this and D is like this. So sorry, it's coming out of the plane. So it is outwards. Or if I take this as X and Y axis, then it is K cap. So if I take X and Y axis like this, then E cross B plus C as a vector is just becoming 10 K cap. This is the left hand side. Now it's very easy to show that the right hand side is this only, because right hand side you will separately do A cross B and A cross C and add the two of them. No, B plus C and A are not collinear beta. Collinear तब होता अगर C का magnitude भी 10 होता, but यहाँ पे C का magnitude 8 था ना, so you can see that there is a slight angle between them. There is a sin theta component. They are not collinear. It's a small angle. It is tan inverse of 1 by 9 root 3, but there is some angle. What you're saying, Atharva, would have happened if I had taken C's magnitude to be 10, same as B, but I took it to be different, 8. So they are not collinear. Okay, so left hand side is clear to all of you. Got this? We'll do, but component algebra though we haven't learned yet. So we'll learn component algebra and then we'll do by that. Right now we'll just go with the definitions that we learned. Okay. So we have seen the left hand side of this is nothing but 10 units coming out of the plane or 10 K cap. Okay. Now let us look at the right hand side. So right hand side of that vector operation was E cross B plus E cross C. So let's do each of these. So E is a vector like this, B is a vector like this, and C was a vector like this. This angle was 30, this angle was also 30. Okay. So let us separately do A cross B first. So A cross B में क्या हो रहा है? E is like this, B is like this. both of magnitude 10, but the angle between them is how much? 30 degrees. Okay. So direction इसका क्या होगा? Coming out of the plane. So A cross B will be 10 into sine 30 n cap. The n cap is coming out. So if I take this as my x and y axis, then it will become k cap. So A cross B, कितना हो जाएगा? It will become 100 into half, so that is 50 k cap. Now similarly, you calculate A cross C and then show that A cross B plus A cross C will give you this. Okay. So similarly, next what we'll do is we calculate E cross C. So for A cross C, the vector E is like this along our x-axis, whereas our vector C is now like this. Its magnitude is less. Its magnitude is 8 units, and this angle is 30 degrees. So you can see in this diagram now, E cross C will become EC sine 30 some different unit vector n prime. Let's say, okay, so this is 10 into 8 into sine 30, and this unit vector will be where now? So point your thumb along A and fingers along C. This will be into the plane. So this will become minus k cap. Correct. Good. So this is becoming minus 40 k cap. Okay, so this is my A cross C. Therefore, the right hand side of the equation, which was E cross B plus A cross C, you will see is now equal to the left hand side of the equation. When you do the vector sum of these two, so you replace A cross B with what we calculated above, which was 50 k cap, and replace A cross C with minus 40 k cap from here. You can see that we are left with 10 k cap, which is equal to the left hand side. Hence true. So this is how, without using any component algebra equations, okay, just by using the basic definition of A cross B, the so-called geometrical definition of A cross B, I have got this. So as I said, it's very lengthy because we are just using plain geometry to do this, but it's just one way to show why it is a distributive property. Just from its definition alone, it is distributive. Okay, people, next step is this. And if you compare it to above what we've got the left hand side, you'll see that was also 10K cap. Okay, so just taking you back to the above step where you saw that left hand side was 10K here. Alright, so that's the distributive property. Okay. Now moving on to something very important. Cross product of any vector with itself is a null vector, because obviously so sine 0 is 0 and this is not defined only. So now next let us look at the standard unit vectors. So obviously from the above property it will be clear that if you take cross product with self, it's 0. Just remember that when you write this like in proper notation, this is a vector on the left hand side. So right hand side has to be null vector. You cannot write it as just 0. I mean it means 0 only, but just technically it's the null vector. Okay. But more importantly now, because our Cartesian coordinate system follows the same right hand palm rule that our vector operation is following now. It's something that we understood earlier. That if you look at the XY plane as like one of the walls of your room, you look at the YZ plane as another one of the walls of your room, but these two walls are perpendicular to each other. And if you look at the XZ plane, for example, as the floor of the room, which is mutually perpendicular to both these walls. So you get the system of mutually perpendicular planes, XY, YZ and ZX, formed by the mutually perpendicular axis. Now remember we had said that Z axis is always drawn such that positive Z axis comes by the right hand palm rule of X and Y. Okay, so same way you will understand here that what happens is I cap cross J cap is positive of K cap. Again use your right hand palm rule. So point your thumb along the positive X axis, your fingers along the positive Y axis, and you will see that your palm points. Okay, so you will see that here what is happening is mod of I cross J is nothing but 1 into sine 90. So its magnitude is unity. So I cross J will give you a unit vector, and direction of I cross J will be along the positive Z axis. So in other words, the operation gives you a vector of magnitude unity, but direction along the positive Z axis. So hence it is K. So that's the justification of this. Now the moment you say this, you can also say the reverse of this, that j cross I, j cap cross I cap will have to become minus k cap, because E cross B is minus of B cross A. Okay, so this is precisely happening because we have drawn our XYZ system also according to the right hand rule, and we are also applying the right hand palm rule for cross products direction. So we are consistent in both the operations. In the definition of Cartesian coordinate system in 3D, as well as in our cross product definition, we are using the same consistent rule, which is the right hand palm rule. That is why it is working out like this, that x cross y is giving you plus z, or I cap cross j cap is giving you plus of k cap, and accordingly j cross I is giving you minus of k cap. Okay, so we will discuss the other cross products also, like j cross k and all that, but before that, let's look at a quick example using this. So just now, we saw something like this, that if a vector E is like this and another vector B was like this, we had just done that calculation that E cross B, given that this angle is 30 degrees and E also has a magnitude of 10, we'd see it was 50 k cap or whatever. So let's use component algebra. Use component notation, and the definition that I cross J is equal to K to find E cross B here, where we are already predefining this as our x-axis and this as our y-axis. Okay. So what we can do here in this situation is we can take E as 10 I cap and B as 5√3 I cap plus 5 k cap, because you can see that B's x component is 10 cos 30 and B's y component